Hey everyone, continuing with our graph sketching, we've looked at how to sketch reciprocal graphs. Now we need to know how to sketch the graphs after we made those transformations that we have learned thus far. So be your scaling, translating, reflection, or your modulus. Alright, so how does graph sketching for the resultant graph work? Essentially, whatever they have written, the sequences of transformations would be the exact transformations your graph would follow. So is it translating in the negative x direction by 3 units, your graph would actually translate 3 units in a negative x direction. And of course, if we're talking about modulus and reflection, they are basically the actions taken. Alright, so just to give an example, we have the first example where we want to obtain f bracket 2x plus 1 whole thing plus 3. So one good start is, first of all, alright, if you can do it this way, is to actually list down the sequence of transformation. It will be easier that way. Alternatively, try to match value by value, which I actually don't really recommend. Alright, so let's begin. So because of y equals to fx, we use the MMA rule where we translate x first, then followed by scale x. So in this case, we translate 1 unit negative x direction because we have plus 1. Thereafter, we will scale. So scale parallel x-axis scale factor half because we have 2x. Then we'll translate 3 units in the vertical, y, positive y direction. Okay, so how do we begin from here? Now, just per usual, we sketch graph, we will settle some asymptotes first. Alright, so we have the x asymptote at x equals to 0.5. Now what happens? We will translate 1 unit at negative x direction, so this x asymptote would go to the left and gets you back x equals to minus half. When we then scale the x-axis, I'll scale parallel to the x-axis by scale factor half, which means that all your x values get halved. So we had x equals to minus half for our asymptote. Now we get x equals to minus half times half is minus 1/4. Then translate 3 units in negative, positive y direction. That doesn't affect our x asymptote at all. Hence, we have the first and only asymptote at x equals to minus 1/4. Okay, now from here again the same thing. Let's settle the different features of the graph. We can actually split the graph into 2 parts, to the left and the right of our asymptotes. So let's figure the special features of the graph on the left of the asymptote. And the main feature is the origin. Alright, what happens? Okay, so we have the x-intercept or y-intercept at origin 0, 0. Then we then had negative x direction by 1 unit. So this then becomes 0, 0, goes over to negative 1 unit, is minus 1, 0. We then scale by half to our x variable, you then get minus half 0. Alright, so 0, 0 becomes minus 1, 0. Now it becomes minus half 0. Thereafter we scale, or rather we translate 3 units in the positive x direction. So this value moves up, graph move up, means you're moving towards the positive x direction, y direction, you get minus half 3. As such, the turning point is now at minus half 3. Okay, then whatever happens just goes on, so now we can just do it this way. Now, one thing to take note is, because you scale by half, all your x values would then be scaled as well. So what you do is, try to make it as tight as possible, something like this. Okay, I will try my best to draw this. I'm not very good at sketching or drawing graphs. Okay, now here's a $1 million question. Do we know the x-intercept in the new graph? Answer is no. Okay, we don't have enough information to know when the graph would intersect at x equals to 0. That means if you actually look at it this way, we need to find the value of the graph at x equals to 1. Because at x, actually it's not really even x equals to 1, this is then y equals to minus 3. And then we have to figure out what happens. So, but we don't have in this case, so forget it. Alright, so this is the left side of the graph. I know it looks kind of weird, but deal with it, I just can't draw. Okay, now look at the right of the asymptote where we have this V-shaped or U-shaped portion, and the main feature is that we have the turning point again at 1, 2. So again, go by the logic, so we can do it pretty fast. 1, 2 becomes 0, 2 because you translated 1 unit in the negative x direction. From there you scale by x, scale by half, and 0 divided by half is still 0, so that's easy. Translate 3 units, then you just get plus 5. Or rather plus 3 to give you back 5. So we have the y-intercept at 0, 5, and that will be the new turning point at 0, 5. Clearly you need to put it a bit higher than the other turning point so that you don't, insult the y-axis. Alright, then from here you just need to sketch the same graph. Again, try to make it as tight as possible because you underwent scaling for your x value, and that will be it. Alright, so this is the first example for our transformations for our graphs, and you guys can actually try out the rest for the modulus +1 as well before I move on to the next video where I'll be going through the remaining 2 questions.